Hello, welcome to my channel. Today we are going to implement NOR gate on dsch and microwind software. So at first we will construct the circuit on dsch, then we will simulate it and get the timing diagram. Then we will save the dsch circuit and make a Verilog file. We will generate a Verilog file. Then we will take the Verilog file and compile it in microwind and get a layout design, an automated layout design on microwind software. So let's start with it. So as you can see from the timing diagram, the result, the output matches the truth table of the NOR gate. For 0 0 we are going to get 1, and for all the other inputs we are going to get 0 as output. The second part of the experiment is layer by layer design on microwind software. So initially we will start with the p plus diffusion and the n plus diffusion, and in the NOR gate we need two PMOS and two NMOS, two PMOS on the top and two NMOS at the bottom. To create PMOS and NMOS, we need to cross the polysilicon layer with the diffusion. So if we take a single polysilicon layer and cross it across a P plus diffusion, we get a PMOS. Then we cross it across an N plus diffusion, we are getting NMOS. So with one layer of polysilicon we are getting one PMOS and one NMOS, but in a NOR gate we need two PMOS, two NMOS. So we take another polysilicon layer and cross it again. So now we have two polysilicon layer crossing at P plus diffusion and an N plus diffusion. This ends up with two PMOS at the top and two NMOS at the bottom. Now we need to connect the PMOS and the NMOS. As we can see from the circuit diagram, we need to connect those in the middle. We need to connect the PMOS and the NMOS in the middle. For that we are going to use metal 1 material. We will also take our output from that metal 1 material. Now there is a problem. The two NMOS at the bottom are not in series, they are in parallel. That means both the NMOS transistors are connected to the output, or both the transistor drain is connected to the output metal. So one of the NMOS is connected already with the metal. We connect the other NMOS to the metal or the connection. This makes the parallel connection. Then we will provide the metal connection for ground and VDD supply. Then we will provide an N well to the PMOS transistors. Then we will connect VDD supply to the N well and clock pulses to the polysilicon layers. As you can see, after we hit run, the timing diagram matches the truth table of the NOR gate. The third part of the experiment is transistor-based design model. You take two PMOS and arrange it vertically. Then you connect the metal portion. That means you're making a series connection. Then you take two NMOS transistor and place it horizontally. You connect the top part of the metal with the other NMOS top metal. Then you connect the bottom part of the metal. This will make an upside down T. The whole arrangement will be an upside down T. Then you take one polysilicon layer of PMOS and connect it with polysilicon of NMOS of one NMOS. Then you take another polysilicon of PMOS and connect it with another polysilicon of NMOS. Then you apply the VDD supply, ground and clock pulses. As you can see, after we hit run, the timing diagram matches the truth table of the NOR gate. And that's it for today's video. Thank you for watching.